The question here, determine the null voltages, meaning what? The voltage right here, they want to bless you. The voltage right here, the voltage right here, the voltage right here. Let me make this ground. That's a 0. So let's call this V1, call this one V2, call this one V3, I'll call this one V4. Find V1, V2, V3, V4. Now notice I have a voltage source here. I can use that as a SuperNode. Here's the thing. If this is really ground, the way I did that, if this is ground, then this is not V1. What's that voltage here? 3 volts. So I know that value. Because this end is 3 volts higher than that end. So there goes one equation. If I put 3 in place of V1, I only have V2, V3, V4. Here's another thing. There's Vx right here. I know actually V2, if this is V2, what's this voltage then? Instead of V3, I can call it what?
1.5 Vx plus V2.
Correct. It's this plus that value. So I can take the V3 out. So right now I can say V3, I'll just write it down, equals. It's whatever that voltage plus 0.15 Vx.
Is it V2 or is it V1?
V2. V1 is gone. V1 is 3 actually. V1 is 3. So V1 equals 3 volts. So once you know the value for that, oh, there's one less unknown. That I don't want to write 3V. It looks like 3 volts. I mean 3V, but 3 volts. That's what I meant by 3V. And this one is dead. Uh-oh. Okay, no problem. Oh. Hey. Before we yank this out of the wall. I'll just go 3. I don't want to write 3V. I don't want people to think 3 times V is 3 volts. The units are volts. So now V3 in terms of V2 and Vx. Now, what about this voltage, V4? Isn't that V3 minus Vx? If this is Vx is labeled plus to minus, plus here, minus here, then this end is that much less than that. Or this end that much more than this. And I know what V3 is, so I can write that as what? V2 plus 0.15 Vx minus Vx, which is what? V2 minus 0.85 Vx. What's the big deal about this? Because if I rewrite these in terms of V2, Vx, how many unknowns do I have? Only 2 unknowns. How many equations I have to solve? Only 2 instead of solving 4 equations by 4 unknowns. So now if I go back and redraw that one, oh, I won't have enough space here. I'll go on the next page. This is 4. 1 plus minus 3 volts. And let me write here 3 volts, so not V1, not V2. This is 3. 2. 2. 4, minus to plus 0.15 Vx, and we said this is V2, and V3 is going to be what? This voltage here is V2 plus 0.15 Vx, and this voltage here is going to be what? V2 minus 0.85 Vx. You can see there's only two unknowns right there. This is ground. That's your reference, ground. So that's the nice thing about rewriting everything in terms of V2 and Vx. That shrinks the math for me from 4 equations by 4 unknowns to 2 equations by 2 unknowns. Now, this is a supernode. A voltage source creates a supernode. So let's define current. You can define the current any direction that you want. I can make it go in that direction. I'll call it I1. I'll call this what? I2. You want up or down here? Through this one?
Down.
Down. I3. Left or right on this one? Right. I4. And this one, left or right? Left. We'll call it I5. I already use I sub 2. There's another problem here. That's also a voltage source here. That's another supernode. Only 2 of them. So let me do KVL at this node. Right here. Or KCL, I'm sorry, KCL. Not KVL. KCL at this node. We said the current in, if you take all the current going in the circuit or the node, should equal all the current coming out of that node. Now remember, this is one big node, all attached to it. So what is going to that? Anything going to it? I5, yes. Is that the only thing going to it? It looks like it, right? And what's leaving that node? I see I1. I see I sub 2. I see I sub 3. I see what, 4? And I'm going to rewrite each one now in terms of the voltages. So I sub 1 is going this way. Since it's going in that direction, it's this voltage minus that voltage divided by the resistor. This voltage is what? 3 minus V2, that's I sub 1. 3 minus V2 divided by 1. I sub 5 on this end, the current coming down this way, so it's this voltage minus this one. What's that voltage? V2 plus 0.15 Vx minus, what's this voltage here? 0 divided by that resistor, which is what? 2. I sub 2, where's I sub 2? That's this one. Coming down. It's 3 minus whatever that voltage here, which is V2 minus 0.85 Vx divided by what? 2 plus I sub 3. Where's I sub 3? That's the current coming down. Down is going to be that voltage minus this one. What's that voltage? 0 minus divided by 3 and plus the 4. And what's my LCD here? The LCD for the 2 and the 3 is a 6, right? So let's multiply the whole equation by 6. 6 times this, that will make it what? 3 times V2 plus 0.15 Vx. 6 times 3 minus V2 plus 3 times, this will be what? 3 minus V2 plus 0.85 Vx. Do you see that, everyone? Minus to minus is a plus. Plus will be what? 2 times what? Negative V2 plus 0.85 Vx. And what's 4 times 6? 24. So I multiplied everything by 6. Sorry guys watching the video, I'm playing with the camera. Here we go. 3V2 plus what? Is that 0.45 Vx? 18 minus 6V2 plus 9 minus 3V2 plus 2.55 Vx minus 2V2 plus 1.7 Vx plus 24. Let's clean the right side. It looks like a mess on the right side. 3V2 plus 0.45 Vx equals. Let's take the V2 on this side alone. Negative 6, negative 3 is negative 9, negative 9 and negative 2 is that negative 11. Let's look at the Vx's. 2.55, 1.7. Any more on this side? Am I blind? That looks like what? 4.25 you said? Vx. And let's look at the constant. 24 plus 18 plus 9. 18 9 is 27. 27 plus 24 is what? 27, 24, 51. Move everything to one side. Oh, look at this. Oh no, I thought it was 4 point. I thought these numbers were the same. I says perfect, but it's not. My eyes are bad. I said, oh, cancel. So bring this one here. That becomes what? 14V2. When you bring this to the side, it becomes a minus. Let's see what that number is. 3.8 Vx equals 51. That's the first equation. I need one more. We can do a KCL of this node, this SuperNode. And that will include all these. Boom, 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 boom. Take a break, huh? Now KCL at this node, the dependent source. The current N, what is going to that node? This is all one node. The 4 is going to it. I sub 1 is going to it. I sub 4 is going to it. And what's leaving? I sub 5?
It shouldn't be the. Yeah.
Go ahead.
I thought it'd be close to the opposite of the one above that we just did.
Well, a little bit different because this one we had I sub 3 in it. So I sub 3 and then the picture there, minor changes there. So this node here, you could, by the way, done this node too if you want to. You know? Instead of that node, you could have done this node.
If we had 3 unknowns, would be
Yep, then you'll do it. If you did the, yeah. If you left them as 3, V1, V2, V3, then you'll do this node, that node, and this node. 3 equations by 3 unknowns. So now let's finish this. That's 4. What's I sub 1? I sub 1 is 3 minus V2 divided by 1. I sub 4, I forgot what I sub 4 is right here. It's this minus that. So what is it? V2 minus 0.85 Vx minus that one, which is V2 plus 0.15 Vx divided by what? 4. This minus that over 4. And what's leaving I sub 5, which is this minus 0. Over 2. And now I just got to play with the math. What's my LCD? 4? So let's multiply by 4. 16 plus 4 times 3 minus V2 plus. Now, the 4 will cancel that 4. I'm going to have what? You know what? Let me just open this while I'm here instead of making another line. I can leave it like this, but I'm trying to look ahead. This is 12 minus 4 V2, right? When you distribute that, let's write it that way. So I don't have to write it twice. 4 times 3 is 12 minus 4 V2. Because now 4 cancels the 4, I will have V2 minus 0.85 Vx minus V2 minus 0.15 Vx. Actually, if I thought about it, if I was smart, and I thought about it, we know this is Vx, right? So I sub 4 is negative Vx divided by 4, because there was plus to minus. If you remember, that was Vx. So instead of using all this gibberish stuff, I could have used, since it's going that way, it's negative Vx over 4. And that's what you're going to get out of this. Negative Vx, you see that? But even if you didn't see it, the math takes you there. And when you divide by 2, multiply by 4, that's a 2. 2 times V2, 2V2 plus what, 0.3 Vx? 16 minus 12 is 4. So what do we have? Negative 4 V2. These two will cancel each other out.
Wasn't that 16 plus 12?
Oh yes, 16 plus the other minus. 16 plus 12, which is what? 28. Minus, these two will cancel each other, negative 4 V2. This is negative Vx equals 2V2 plus 0.3 Vx. Move everything to one side. Move this one there, move that one there. You'll have 28 equals what? 2 and 4, 6 V2 plus, is it 1.3 Vx? And that's your second equation. Now we get 2 equations by 2 unknowns. Let me go to my calculator, go to my simultaneous equation. I want to do a new equation. It's 2 equations by 2 unknowns. So here we go, 6 and 1.3, 6, 1.3, and 28. And the other equation is 14, negative 3.8, and 51. And there's V1 and Vx, or was it V2 and Vx? V2 equals 4.2122, and Vx equals 2.09756. The question was, what's V1, V2, and V3? Well, once I know these, can I find V3 and V4 from here? So, V3 equals V2, which is 4.2122, plus 0.15 times Vx, which is 2.097, whatever that number is. Home. Clear. Okay. So it's 4.2122 plus 0.15 times Vx, which is 2.09756. 4.52. And you want to find V4? V4 from early, we said that's V3 minus Vx. V3 minus Vx. We know what V3 is. We know what Vx is. Subtract them. 4 minus 2.09756, which is 2.42927. We know V2, V3, V4, V1. The numbers in the book a little bit off. So let me just take a peek and see if I copied something wrong first, or maybe I had a math error somewhere. 4, 4, 3, 2.11, 4. That's what I got for a value there. So it could be a combining. Maybe I missed one when I combine. It's possible. Negative, that's 6V2. That's negative Vx. Comes a plus. That's 1.3. It could be in the other equation when I combine them. I could be wrong. The book could be wrong, but probably one of these I combine. Maybe I left something out. Negative 6, negative 9, negative 11 V2, 2.55, 1.7, 4.25 Vx, 18 and 9, 27, 2051, 14, looks like I'm okay there. Just from here to here, it looks like I didn't check that step here just to make sure, you know. But you get the idea. I don't know if I made a mistake or not. Honestly, I don't know if the numbers are added wrong somewhere. But you do SuperNode. SuperNode here, SuperNode there. Two equations by two unknowns. If you still call them V1, V2, oh, you know V1's 3. If you call them V2, V3, and V4, then what you got to do is three equations by three unknowns. You still got to do one right here. If you did that, you'll call that V1, 3, V1, or V2, V3, V4. There's three unknowns. You need three equations, 1, 2, 3. KCL at each node. But you can use a SuperNode and do some substitution to shrink that to two equations by two unknowns. The only problem when you do that, you know, the math is not really pretty. You can see that. Like, find the current through that. Look at this current. This minus this over 4. It might have been easier if you just left it V2, V3, you know. I could also push the wrong button on my calculator. I am horrible with calculators. That's probably most of the feedback I get on this. Boy, you missed that problem on YouTube. You typed in you did the procedure correct, but you typed in the wrong number there, or you hit in the wrong key. The answer should be this, the answer should be that. I'll be the first one to admit, I am horrible on calculators. I don't see half the stuff on them. Like whoever designed this, I'm not happy with him or her, because I can't read half the numbers. I can't tell if they're 2s, 4s, 0s, O's, 8s. Okay. Again, I could have done the problem with a different approach. I'll try another one instead of what I did here. It's not the same one. You know what? I could do that. I'll try a different one. I'll try a different one. It gets boring. Let me try a different one, but instead of calling them like what I did here, instead of calling that V2 and this is V2 plus 0.15 and this is V2, maybe I'll call them V2, V3, V4. Something similar to that and see if that's easier. Give it a try. So let me try a different example, similar to that. So I'll take this example. Nope, leave a space on the top because it's going to be the same picture. So I'm starting from the end here. Now I'm going to go higher here. Here we go. This is 12. Point 5. 14, not 4. 14. 1. Down here 2.5. And let's put a dependent current source here. We usually don't deal with a lot of dependent sources, so let's put them there. 0.5 Vx. I'll find or Vx. Let's put a dependent voltage source here too. Let's go crazy with it. And the value of that, 0.2 Vy. One is Vx, one is Vy. And let's put a 2 ohm resistor here. Let's define Vx as this voltage, plus to minus Vx. And let's define Vy, this voltage, plus to minus Vy. Again, I'm going to do them a little bit different than the other problem. And if I label this as my reference, my ground, that means 0 voltage. What's the voltage here?
Negative 12.
Negative 12, yes. There goes one unknown. Let me call this V1. Let me call this V2. Let me call this what? V3. If you don't want to use what I did before, if you don't like what I did there before, try this approach. KCL at V1. Now, let's assign current. So go ahead, shoot. Which way you want the current through the 0.5 ohm?
Up.
Up? Okay. We'll call it I1. How about through the 2 ohm resistor?
Down.
Down, I2. So notice we don't think about it. Through the 1 ohm resistor here.
Up.
Up, I3. This resistor, left or down, up and down. Down, I4. Okay. This is a super node, if I need it. This is a super node if I need it. KCL at V1. What is the current going to that one?
I1 and
14, yep. I sub 1 plus the 14. What's leaving?
V2, I2.
I2. we define I sub 1 going up there, so it's this voltage minus that voltage, so negative 12 minus V1 over a half, 0.5, plus the 14, I sub 2, where's I sub 2? Going down, V1 minus V2 over 2. So if we multiply the whole equation by 2, that's a 4, right? 2 divided by 0.5 is a 4. That's 4 times negative 12 minus V1. 2 times 14 is what? 28. V1 minus V2. So this is negative 4 V1. When you take it to that side, that's 5 V1 minus V2. What's that? Negative 48 plus 28. Is that negative 20? That's the first equation. Again, if I did everything, sometimes it's worth taking that extra minute, do the math. I try to cut a corner here and there. Makes it a little bit challenging. Negative 4 V1 with the V1, that's 5. V2, that's negative 48, and 28, negative 20. KCL at V2. Well, here's the problem. I can't do KCL at V3. Why? V2 and V3 is the same node. It's a SuperNode. So I can only use one of them. KCL at V2. This is considered one node. So if you do this or that's the same one. So what is the current going to it? The current going to it is what? 0.5 Vx I see going to that node. What else I see going to it? I sub 2. What else going to it? Where's I sub 4? Left side, left side. Bottom left. Oh, yes. Going to, what's leaving that node?
I3.
Yep. So if our eyes are good, I said our because mine I didn't even see I sub 4 going to it till you told me. The current going in, that's this equals the current leaving, that's that one. Now I don't like to use Vx because adding Vx is going to introduce another variable. Where is Vx? Vx is labeled plus here, minus here. Can you see it? Vx is labeled plus on this end, minus. So it's this voltage minus this one. That's what Vx is. So 0.5. In place of Vx, I'm going to write what? V1 minus negative 12. That's what Vx is. It's this voltage minus this.
How come for the last, if you go back to what you did at V1, like
This one?
yeah, why did you do 12 minus V1?
Because we defined the current going up. You told me you want it going up, right?
Yeah.
So if it's going up, it's this minus that. If you told me you want the current coming down here, instead of up, down, would be this minus this. But I'm just talking about Vx. Vx is labeled plus to minus. It has nothing to do with I sub 1.
Yeah.
They labeled that for us, plus on the top, minus on the bottom. So it's this one minus this one.
Why don't we need to divide it by the resistor?
Well, that's a current source, right?
No, well, like up there.
Vx?
Yeah.
I'm just talking about V. I'm not talking about the current. Otherwise, they're not saying what's the current. I'm saying this current going in is the value of that 0.5 times Vx. And I'm going, what is Vx? Just V. I'm looking for the voltage, not the current. So it's that voltage minus this voltage. If I was looking for the current, I'll divide them by the resistor, but I'm not. I sub 2, where's I sub 2? Notice now I'm looking for the current. So it's this voltage minus that one divided by 2. I sub 4. Oh, is that I sub 4? Yeah, that's this one. We define it coming down again. So it's negative 12 minus V3 divided by 2.5. And what's leaving? I sub 3, which is what? V3 minus 0 over 1. LCD probably 10 here. If you multiply by 10, you get rid of all the fractions. What's 10 times 0.5? That's 5. V1 plus 12. I'll come back and finish it. 10 divided by 2 is 5. V1 minus V2. This is 4. Negative 12 minus V3. 10 times V3. 5V1 plus 60 plus 5V1 minus 5V2 minus 48 minus 4V3 equals 10V3. 5 and 5 is what? 10? 10V1. When you take it to the right side, negative 10V1. V2, negative 5. When you move it to that side, becomes what? Positive 5V2. V3, when I move this one there, that's plus 14, right? And what's left on this side? What is 60 minus 48? Is it 12? Again, if I collected like terms, if I did a good job with them, there's my answer. Now I need one more equation because you know you have 3 unknowns. I got 1, 2, I need one more.
We have Vx already in terms of V1, so we just plug that into the V3. Like V3 is really V2 minus Vx, right?
Which one? V3?
Oh, no, never mind, that's Vy down there, never mind.
Yep.
Never mind. I thought
Yep.
the
oh.
voltage source there was Vx.
Well, you can figure out, you can write V3 in terms of V2 if you want to, right? It's this voltage minus 0.2 Vy and figure out what Vy is. Or now you can do the KCL of this node too. That's the other option. Did we do that node yet?
No.
You know? So I can do that, or I can come up with an equation that will tie V2 and V3 together. Actually, it's not a bad idea to look right here. If you want to make the math easy on you, instead of KCL of this node, because when you look at that node, this is the same node, so you gotta look what's going to it. This going to it, this one going to it. What's leaving the node? This one, that one, and that one. It might be easier just to use that one. Go, you know what? This is minus to plus. This end here is what? It's whatever this one minus that one. You can get your third equation much easier that way. So if I do that, I can write here V3 equals V2 minus 0.2 times Vy. But now I got a Vy in the problem. That comes from here. Here's Vy. Look how Vy is defined. Plus here, minus there. Just the voltage. So it's this voltage minus that voltage. Does everyone see that? So it's V3 minus a minus 12. So this will be V3 minus a negative 12. we do the math, we should have a third equation now. V3 equals V2 minus 0.2 V3. Minus a minus, that's a plus 12. So what's negative times a positive is negative. What's 0.2 times 12? Is that 2.4? 0.2 times 12.
It is.
Let's move everything to one side. You have negative V2 plus what? 1.2 V3 equals negative 2.4. Notice there is no V1. So if I'm going to be using my calculator, I should write what? Maybe 0 V1? So I know V1 is 0 because I'm trying to have V1, V2, and V3. And the same thing right here. Notice there is no V3. So what do you do with V3 here? You can say plus 0 V3, right? So now every equation has V1, V2, and V3. I have 3 equations by 3 unknowns. I will go to my calculator now. There goes my friend. Uh-oh. Catalog app. Where's app? Is there an app button? Besides shutting it off and turn it back on? I'm sure there's a way to get to it. To get to this screen without having to do that. But I don't know it yet. So 3 equations by 3 unknowns. Let me begin with this. 5, negative 1, 0, negative 20. That's the first equation. The second equation, negative 10, 5, 14, and the answer is 12. Third equation, 0, negative 1, 1.2, and negative 2.4. Again, if I push all the right button on the calculator, and I go calculate, give it a few seconds, and here's the answer. The answers are V1 is equal to negative 4. V2, it looks like it. Here's what the calculator gave me, which you know that's a 0. That's what the calculator gave me. That's a 0. And V3 I got to be negative 2. And we know V1, that was what? What was V1? Was that negative 12 from the picture? That was V1 here. That's a negative 12. So these are the answers for all of them. And it does happen to match the example here. When you have a TI like this, it really doesn't matter. Like I was concerned earlier about when I did this to do them 2 equations by 2 unknowns, because I'm thinking some people don't have the TI-89, they got to do it by hand. And if you got to do it by hand, I'm sure you'd rather solve 2 by 2 instead of 3 by 3. But if you have a calculator that does the work for you, then who cares if it's 3 by 3, 4 by 4, 5 by 5? Just plug in the numbers and hit enter. It tells you what the answers are. But for those people doing it by hand, it's a different story.